Number 53, determine which of the following are one-to-one functions. When it says one-to-one functions, that's what the key thing is here. A one-to-one function means it has an inverse function. If it has an inverse function, that means it'll be able to pass the horizontal line test. So what we do to do the horizontal line test is we'll put a pencil here, and we'll see if it only touches, if the function touches the pencil more than once, like in part 1 right here, we can see that it touches it twice, then we know it is not a one-to-one function. So in this one, it touches it twice, so this is not a one-to-one function. Let's look at part 3 here. Obviously, if we do the horizontal line test, like right there, we'll see that it touches it twice, like on our pencils. So that is not a one-to-one function. Okay, number 4, right here, it only touches it once. Right here, it only touches it once. Okay, what about like right there? Do you think it touches it more than once? This is sort of similar to what we've talked about in class. There's a horizontal asymptote right here. Now you know what a horizontal asymptote is. So there's a horizontal asymptote here at y equals 0. It'll never touch that line. It'll never touch y equals 0. So it's never gonna cross it, and it will always just keep getting smaller, 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 smaller. So what happens as we get closer and closer and closer, it'll still only be one value that it'll ever be. It will never like curve back up or anything like that. It'll just keep getting closer and closer and closer to that y equals 0. So therefore, this is a one-to-one function. It also goes for this problem too. I know we didn't discuss rational functions when you took this test the first time. Now you're familiar with it. You have a asymptote here. It looks like it's like y equals -2. And then, well, we also have a vertical asymptote. We might as well just point it out. That's at x equals 0. Okay, but again, if we look at this function, so it'll get continually closer and closer and closer to y equals -2, continually closer. But it'll never turn back around. It'll never turn back around. If it turned back around, that means we would have a non-one-to-one function, right? But what happens is it just keeps getting closer and closer and closer and closer and closer to that -2. This is a one-to-one function. So the answer here is A.